Good afternoon, everybody. Today I'm going to talk to you about something called the radius of the arc. And I'll just try to draw a picture for you. Radius of the arc. And what I'm going to do is I'll just draw a picture and cut down on some of the commentary here. This is a fairly interesting math application with respect to architecture, I guess, or just construction. Radius of arc. So now what I need to do here is figure out a way to draw a circle, folks. So let's see if we can manage that. And what do you know? That's not a bad looking circle. All right, now, again, y'all, I'm kind of experimenting with this new little toy I have here. I need to draw a straight line here. Isn't bad, isn't bad. All right, everybody. Now, this little segment that I've drawn here is called, it's just called the arc, I guess, or maybe a segment, I'm not sure. But anyway, this segment has a chord length right here. We're going to go ahead and call that W. Okay. Now, so this length right here is W. Let me see if that works. It's working out okay. Now, this distance right here from here to here is called the height. Okay, so I'll just put H here, and hopefully that'll be clear in context. Okay. So the height is the vertical distance. Now this is a midpoint. It bisects right here, and this is the width. Okay. So again, I'm trying to avoid a little bit of clutter right here. Now, what we have right, the radius of the arc is the actual radius of the circle. Okay, the radius of the circle that would create this arc. So you see from here to here. Well, I think you get the picture, folks. We're trying to find the radius R of the circle that would create this arc, okay? And we want the radius. It obviously has to be in terms, okay? R has to be in terms of H and W. It has to be a function of H and W here for this to make any sense. In terms of H and W. Now, mathematically, you just say a function of H and W, but we'll just say in terms, a little more colloquial here, in terms of H and W. The height and the width of that arc, folks. The height and the width, okay? We want to get R in terms of the height of this arc and its width, all right? Now, what I'm going to do is I'm going to draw another picture right here to help clarify this. We're trying to find the radius of the circle that produces this arc, okay? Now let me draw another circle here, see how this goes. Okay, now that's intended to be a circle, ladies and gentlemen. Now, so what we're going to do right here is try to perform this computation of this proof. All right, so okay, folks, not the most professional job, but it does meet the conditions here. Okay, now so folks, this distance, this is still H right here, but if we want to sorry, y'all, this is a little confusing here. If I could just make it do what it was supposed to do. Okay, I'm gonna put a little mark right here, folks. Now, y'all right here, what I want to do is call this W over 2. There's a result about chords here, ladies and gentlemen, that's going to come in handy. So I'm going to call this W over 2 and W over 2 right over here. All right. Or this entire distance over here is W, so we're splitting it. We're bisecting right here. So this is W over 2. This is W over 2. Okay, now let's go ahead and draw another line here, folks. Let's see. Yeah. Everybody, I'm trying to draw a line straight through that point there. Okay. Not too bad. Not too bad, even though my circle looks a little like an egg. All right, good enough, folks. Now, so here we have it. Now let's get things labeled here. Let's see here. We need to draw here. So this is still H right here. Still H. And this is X. You'll notice that the radius is somewhere in here, but we don't really need to locate it to determine this proof, because we know that H plus X is going to be a diameter. Let's write that down. Okay, so H plus X is equal to the diameter. Equal to D, we'll call it D, right? Okay. Now, y'all, there's a result. There's a result called the chord theorem, which says this: if you take the product of this segment, this chord segment with this chord segment, you get W squared over 4. Okay. Okay. And that's equal to the product of these two chord segments, which is HX. Okay. HX, right? Y'all comfortable with that? So, or again, the chord theorem says that if you have any two chords that intersect, the product of their segments is equal, and that's exactly what this says. This is W over 2 times W over 2, which is W squared over 4, and HX is the product of the vertical chord segment, right? Now, we want to get everything in terms of H and W, as we said here at the beginning. We want to get everything in terms of H and W. So we can replace X with, okay, we can see that X is equal to D minus H, right? So I'm going to put D minus H. This is getting a little sloppy. My apologies. I hope that's legible for you. D minus H. Okay. Now again, so folks, we have everything in terms, the X has been eliminated because of this relationship between H and X. So right here, we end up with, let me come up, I'll try to write right underneath it, folks, and see how well this works out. We still have W squared over 4 equals to H D minus H squared. Right? Okay, y'all. And you see, we are trying to find the radius in terms of H and D. So if we keep going here, let's see here. Am I running out of room here? Well, I think I still have enough room. Okay, so this would be equal to, now y'all right here, I'm going to exploit the truth. What do we need to do right here? We know that D over 2 is the radius. Okay, right here, let me do this. D over 2 is equal to the radius. It's equal to the radius R. All right, so D over 2 would be H plus X over 2. So let me write that down. Okay, we need to replace the diameter with h plus x over 2. Sorry. Okay, folks. So what we have right here is h, okay, times h plus x over 2. Now, there may be a cleaner way to do the algebra here. I don't know. Let's see. Oh, sorry. Look, y'all made a mistake there. Let me clear this out. That's not going to help any what I was just saying. We're trying to get the radius to drop out of this, folks. So the radius is equal to h plus x over 2. Okay, so how do we get this resolved, folks? Oh, this is getting so weird. Here we go. All right, now, what's the best step to accomplish this simplification, folks? D over 2 is equal to R. All right, D over 2 is equal to R. And so we can replace D with 2R. Sorry about that, folks. I was all messed up there. So we can put a 2R right here. Made that a lot harder than it had to be. Let me erase it. Okay. We're going to put 2R right here. Okay. You see, we do want everything in terms of R. That's where I was getting screwed up. Okay. And then minus h squared. Like that. All right. And so what do we end up with here, folks? When all is said and done, we got, let me come on over here and write, folks. We have w squared over 4 still. Okay. Plus h squared. Okay. Is equal to h times 2r. You see, y'all eventually are going to be able to algebraically isolate this for r. Okay, getting close to the finish line here, ladies and gentlemen. We're trying to solve this expression for r, so this just goes back to fairly routine algebra right here, folks. What you're going to get here is r. Yeah, I'll leave out a few steps here. I know everybody hates that. I usually make mistakes when I do that. But this would be w squared over, let's see, I'm dividing this by 2h, so that would be 8h right here. Again, y'all, I could show you a few more steps here, but we'll trust that everybody can handle the algebra here. And then plus, okay, we're envision dividing h squared by 2h. That will be h over 2. Okay, y'all, so now I wish I could draw more on this. I'm going to leave it at this. This is your formula for the radius of the arc. In other words, this r that you see right here, if we knew what h and w were, h and w are given to be constants, but you could just substitute the value for the width of the arc and the height of the arc. And you would get this radius of the bigger circle, of this whole big circle that created this. All right. So that would be useful maybe, you know, where if somebody wanted to draw the exact dimensions of this arc or recreate it, you would just get a compass and draw the entire circle with this radius that you calculated, and you would be able to get this arc up here. Okay, now that I'm not sure if that's exactly how they do it, but it would work. All right. Again, I wish I could show you a concrete example, but for any W and H, you will get the numerical value for the big circle that would create this arc. Okay, thank you. Thank you for listening. I hope that helped.